The last thing we're going to take a look at in this section is being able to kind of graph some of these slope fields and also what the differential equation might look like. So a slope field is essentially going to be the result of plotting all the slopes that result from the differential equation. And you guys remember from Calc 1, the first derivative of a function represents the slope at that particular point. All right, so if we have a point that falls somewhere within the domain by t, that means that that's going to dictate what the slope looks like at that point. So for instance, if we were to pick the point 1, 2, what we would do is we would plug 1 in for t, 2 in for y, and that would give us a slope of 3 at that point. So y prime at 1 is equal to 3. And so a slope of 3 is going to be a steep sort of slope in a positive direction. So it's going to look something like these guys right here. All right. So what we do is we just put like a little hash mark at each of those points to represent what the slope is. All right. Of course, doing this, if we look at this graph right here, notice that there's about 100 tick marks on this. Okay, probably a lot more than that, probably a couple hundred. So that could be really tedious for us to do by hand. And so what we probably prefer to do is use some sort of technology. All right. And one really nice program that helps us out is going to be Desmos. And Desmos has this slope field plotter, excuse me, and that could be able to help us to be able to get what a more accurate graph might look like. But we should certainly be able to do one a little bit by hand. One of the other things that we're going to do is once we have the slope field, we're going to be able to plot what the particular solution looks like at a given point. Okay, so what I could do is, let's say I want to look at the point 1, 1. Okay, or in other words, if f at 1 or y at 1 is going to be equal to 1. All right, for some reason, if I want to look at that. What I would do is I would go to the point 1, 1, which would be right about here, and I would just follow the curve. All right, so I just go here, and then I just keep following this. And that's what we mean by what the particular solution looks like at a given point. And of course, if we get like, some sort of technology makes it look a lot better. But this isn't far off, okay, just by doing it by hand, okay? So you just basically follow where the hash marks go. All right, so let's take a look at a couple examples of this, okay? So let's have a really basic differential equation. Y of x is equal to 2x. Let's plot the slope field by hand, which is going to be pretty taxing. Then we're going to plot the slope field using technology, which is going to be really easy. And then we're just going to try to graph the solutions to this, okay? So if we have a table of values, so let's say we have x and y, and then we have like our y prime equals 2x. All we're doing is just multiplying the x value by 2. So let's say we had like the point 0, 0. Well, 2 times 0 would be 0. Okay, so that means that the slope at the point 0, 0 is 0. Right? Now, let's say we had the point 1, 0. We would multiply that by 2. All right, since the slope is going to be 2x, and that would be the slope at the point 1, 0. And then at the point 2, 0, the slope would be 4. At the point 3, 0, the slope will be 6. In the opposite direction, if we had the point -1, 0, that would give us the point negative, or the slope of -2. And at the point -2, 0, that would be -4. And then finally at the point -3, 0, that would be -6. All right, so if we were to plot all of these on a curve, or I'm sorry, on a graph, all right, so, and I'm just going to say 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. All right. And so if we graph these at the point 0, 0, the slope is 0. All right. So right here, the slope is 0. At the point 1, 0, the slope is 2. All right. So I have like this positive slope. All right. That's not too steep, but not flat. At the point 2, 0, the slope is going to be 4. Okay, so that's going to be a little bit steeper. All right, and then at 3, 0, the slope is 6. So it's starting to get to the point where it's almost vertical at that point. All right, so that's what we mean by the slopes at those points. Okay, it just keeps getting steeper and steeper and steeper as we keep going along. Right. Of course, in the opposite direction, it's going to be a negative slope. Okay, so right here, we're going to have a fairly tame slope of -2 approximately. And then here, this is 4. And then it starts getting almost vertical right there. Okay, so that's all these guys right here. Now, of course, at any point, we could just multiply the x value by 2. So let's say we look at the point 2, 1 right here, then the slope is just going to be 2, all right, which is going to be the same as what we had there. At the point 1, 2, all right, we just multiply 1 by 2, we get another slope of 2, and then finally we get the same thing, and that's going to be a 2 as well. And then here we get 4, so we get a little bit steeper, and then finally, like it's almost like vertical at this point. Okay, so all we're doing is we're just multiplying each of the x coordinates by 2 and just putting the slopes in there. Okay, over here we do the same thing. So -1 times 2 is a -2. -1 times 2 is 2, -2. -1 times 2 is -2. All right, and then here we have the point -2, 1, so we get a slope of -4. Okay, and then this is going to be -6. All right. And of course, if we go below the axis and we start multiplying everything by by positive and negative, we're going to get the exact same thing. Okay, so this is going to be +1 times 2, and then +2 times 2, and then +3 times 2. All right, so, and then finally over here, we're going to get the same thing. So -1 times 2, -2 for all of those, and then -4. And then finally -6. All right, so this is what our basic slope field looks like. Okay. Oh, and by the way, on the on the y-axis, the x is always 0, so these are all going to be flat. All right. So hopefully that makes sense to do it by hand. Okay, so all we're doing just multiplying all the x values by 2 and just putting a tick in there. Okay, to be able to kind of represent those. And I know this isn't all that accurate, but it could be a lot worse. Now, let's see what Desmos gives us. Okay, so what I'm going to do is I'm just going to go ahead. I'm going to copy this link and I'm going to paste it right into my URL. All right. And to work with Desmos, just go over here to line 2, and you're going to replace this function with the function that we're working with, which is going to be 2x. All right. And notice, and we could zoom in too, all right, because we only did from 0 to 3, all right. And these were kind of our graphs that we got out of this, all right. And this is just like kind of, moving the slope, so you can kind of see what's happening to the slope as you move it along. Okay, so this is actually a pretty cool tool that you can see like at any point. I'm just going to kind of put it on the origin so we can kind of mask it. Okay, I really don't want it doing anything to us. But if we take a look at this, and then we can kind of compare it to our graph here. Okay, if I zoomed in just a little bit, so that way I'm just looking at our graph, they don't look too bad. Okay, comparatively. Okay, so I'm looking at this guy. We have all 0 slopes on the axis, and we have all 0 slopes on the y-axis. And then remember, we said that the slope is going to continuously get steeper as we keep getting further right and also further left. Okay, so this actually looks pretty close to what we just did here. Okay, obviously Desmos is a lot better because we did it by utilizing technology. Now, the last part of the problem is to plot the graph of the solution that results with the initial condition y at 0 equals -2 and y at 0 is 1. So all we're going to do is we're just going to trace what happens, and I'm going to do it in a different color. All right, so let's use something like, let's use red or maybe green. Green's probably like the most contrast color that I can think of at this point. All right. And so that means we're going to go to the point 0, -2 and just trace. Okay, so if I do that, then we just get something like this on this side, and we get something like this on this side, and we get a parabola. Okay, so this is y at 0 equals -2. All right, and then we also want to do the same thing, y at 0 equals 1. All right, so maybe I can use like gold or something like that. All right. So I'm going to go to point 0, 1. I'm going to trace. All right, it does the same thing. All right. which makes sense because if we were to solve this differential equation, right, by just integrating both sides, so integral of y prime at x dx equals the integral of 2x dx, okay? Well, we know the antiderivative of y prime is going to be y at x, and the antiderivative of 2x is going to be x squared plus a constant, right? So basically, we would get a family of parabolas, okay? And certainly, okay, that's what we end up with here, okay? So this is actually, and we could go through, we could solve the particular solution, but the one in green that we just drew, okay, this is just going to be the parabola y equals x squared minus 2, right? And then the one in gold that we just constructed, okay, that's going to be y equals x squared plus 1. And if we know the solutions, we can go to Desmos, okay, and right here we could actually plot those. So if I said y equals x squared minus 2, okay, we could just go ahead and get the parabola, right? And then over here, I could do the same thing, y equals x squared plus 1. We could get the parabola as well. And of course, we can zoom in and out on this, right? We're not bound to be able to just stay in here. All right, so this is how we could use technology to be able to graph. And then, but we could certainly also do it by hand. Okay, now by hand, my graph isn't as accurate. But again, I should have an idea as to how to try to do this by hand if I really wanted to. Okay, but Desmos makes it a lot better for us because we can just go ahead and plot that way. Okay, all right, so pretty cool that we can go ahead and graph these slope fields. So we're going to take a look at one more example in a subsequent video. But for right now, this should help you to at least get a general idea of what a slope field is, how the particular solutions can be plotted on those slope fields, and also the family of solutions, what they might look like as well.